Hello and welcome to Inverse Trig. A lot of this has been building up. How do we use SOHCAHTOA, trig ratios, solving for sides using trigonometry, and now we get to solve for angles this time. So last time we solved for sides, this time we're actually solving for angles, and that's where inverse trig comes in. This is used to solve for angles. And you could put for theta, or you could put for angles. Okay, and what's nice about inverse trig is that you could actually do this with two sides. So you could be given, wow, that's a terrible G. Given two or more sides. Okay, so we're going to be solving for angles this time. Okay, and if you look at our first example, solving for theta means we're solving for the specific angle measure. Okay, your calculator is going to be extremely important in this particular problem. And if you actually notice this first problem, we have a hypotenuse and an opposite side that are, the hypotenuse is double one of the sides, which hopefully you recognize, because whenever you have one leg that is double to make the hypotenuse, that is actually a dead giveaway for 30, 60, 90. Most particularly, this is going to be b, this is going to be b root 3, and this is going to be 2b. So which means this particular angle is the 30-degree side, the 30-degree angle. And if you recognize that, awesome. You actually could just assume that the theta is 30 degrees. But if you don't, I'll show you how to do that with inverse trig. So looking at this, I'm going to put my person right here. This is where we're looking at it from. We have the opposite and the hypotenuse as mentioned. So we're going to work with, well, we probably should also write this up here. SOHCAHTOA and if you have that, then you could actually start, if you recognize, okay, we have sine, we have opposite and hypotenuse, which means it's sine. We don't need this at the top of your page by now. Awesome. But I personally would always write that at the top of every assignment or any test or assessment that you have. So we're working with sine in this first problem. Sine of theta, because we actually don't know what the angle is equal to opposite, which is 10, over a hypotenuse 20. It is not necessary to simplify this. I personally would not leave it as it is. It's going to be much easier this way. Unless you have really large numbers there, I would leave it as 10 over 20. Okay, so to get we actually need to solve for theta. So this time, we need to solve for theta. Solve for theta. And the way we do that is we actually have to get rid of sine. And it's most people's instincts to actually divide sine out, which is incorrect. You cannot divide sine. This is a function. So we actually need to take the inverse function. It's kind of like saying, okay, if we have, I'm going to do this in pink, if you have x plus 9 is equal to 10, the inverse of addition is subtraction. You get x is equal to 1. Or if you have 3x is equal to 12, the inverse of multiplication is division. And x here is equal to 4. Trig functions have their own inverse functions. And it's going to sound strange to see this, but the inverse function, or the inverse function to sine, is inverse sine. It's going to be sine to the negative first power. And if you look in your calculator, right above the sign, in blue, it says sine raised to the negative first power. If you hit second and then you hit sine, you get that sine to the negative first. So anything you do to one side, you have to do to the other. And you're going to want to open up a parenthesis. This 10 over 20 is going inside that parentheses, okay? And then the sine and inverse sine on the left cancel out. And now theta is isolated. Theta is now by itself, which is what we want. So in our calculator, we are going to do inverse sine, which we already have in here, but just to demonstrate it again, hit second, hit sine, and then you get inverse sine. You're going to do 10 divided by 20, and is equal to 30. Now, if you simplified it, 1 over 2, oops, inverse sine, 1 divided by 2, you get the same answer. So that's why I say personally, leave the 10 over 20, because it's not going to affect your answer. So theta here is equal to 30, but theta, remember, is an angle. So we actually have to write this as a degree. So we, instead of writing just 30, we put 30 degrees. And remember I said we're going to be using this to solve for angles. All right, now let's solve for the next one. Solve for theta. So once again, we have an angle here that we want to solve for. Let's put our person here. And then let's label these sides. Hypotenuse is over here, right across the right angle. So we actually don't have the hypotenuse. 6 should be the opposite side. 8 is the adjacent side. And we could solve for that. We could solve for the angle. Which trig function works with opposite and adjacent? Hopefully you said tangent. So we're going to do tangent of theta is equal to opposite 6 over adjacent 8. And just like the last problem, the inverse of tan is inverse tan. Anything you do to one side, you do to the other. Parentheses opens up, and this will go on the inside of that parentheses. Tangent and inverse tangent cancel out, and theta is now by itself. You could simplify 6 over 8, but as I previously showed you, it's not going to make a difference. So, inverse tan. Second, oops, let's clear that out. Second inverse. And we get 6 divided by 8. And we get 36.869. So this is actually going to be an approximation this time. So let's make sure we do an approximation. 36.87 degrees. So the hundredths place is a nice place to round. And we are done. Okay? So we have 2 angles solved for using 2 different trig functions and their inverse functions to actually solve for those particular angles. Our third example is going to be kind of a long one. Solve for all the missing sides and angles. So we need to know what this length is, which we could do. We need to know what the angle is here. And we actually need to solve for this last one. I'm going to call that alpha. Okay? I'm going to call this x too while we're at it. So depending on what you want to solve for first, you could actually solve for x, theta, or alpha, depending on the problem. So, for instance, if I wanted to solve for alpha, I would use sine, because opposite and hypotenuse. If I wanted to solve for theta, I would use cosine, because it's the adjacent and the hypotenuse. And if I wanted to solve for the last side, I have 2 out of the 3 sides in a right triangle. I could actually use the Pythagorean theorem. But let's solve for theta first, because that's what was originally that's what's written in black. So let's start there. So I'm going to put my person here, and let's go. Let's start. So let's say this is the adjacent side. Let's say this is the hypotenuse side, because it is, and let's start solving. Which trig function works with hypotenuse and adjacent? Well, that's cosine. So we have cosine of theta is equal to 12 over 15. Now, just like the other 2 examples, we need to get rid of the cosine, so we do inverse cosine. Anything you do to one side, you do to the other. Open up a parentheses, throw this ratio in, inverse cosine and cosine cancel, and we get theta by itself. Once again, do not simplify the ratio. Inverse cosine of 12 divided by 15 is equal to 36.86. I'm going to write this as, well, ironically enough, it's the same angle from above. And that's not a coincidence. 36.87 degrees. And now we actually have that. So I'm going to put 36.87 degrees. And that should be an approximation. Now, this next example, or let's say we want to solve for alpha. Okay? Alpha, if you actually notice, we have 2 out of the 3 angles in the triangle. So we could actually do this without doing inverse trig. Because if you know, there are 180 degrees in a triangle. And we already have 2 of them. So 180 minus 90 minus 36.87. Or personally, I would just do 90 minus 36.87. Because as we know, the 2 non-right angles are always going to be complementary. So I personally would just take 90 minus 36.87, throw that into our calculator, and we get 53.13. So in this particular case, alpha, 53.13 degrees, this is an approximation, and we're done. Well, with the angles. Now we need to solve for x, okay? So, solving for x, let's do this. Let's make sure it's color-coded properly. Let's say this is alpha in blue. Okay, Pythagorean theorem. So we need to solve for x. We don't know what it is, but we do know that we have 12 squared plus x squared is equal to the hypotenuse squared. 15 squared. 144 plus x squared is equal to 225. Subtract 144 from both sides. And you get x squared is equal to 81. Square root both sides. X is then equal to 9. So x is equal to 9 here. And that is a Pythagorean triple, if in case you were wondering. It is a multiple of 3, 4, 5, which this was also, if you actually notice, 6, 8, 10. And that's why these angles turn out to be the same angles. If you did catch that, awesome. If you didn't, that's perfectly fine. But just know that there are those multiples that kind of play out, and then they actually have equivalent angle measures, which we saw here with these 2 angles. All right, so using inverse trig, you need to make sure you are 1 in degrees, and then 2, you're using inverse trig functions. Remember, this is only used to solve for angles. Regular trig for solving for sides. And sometimes we're going to be asked to solve for all the missing pieces as needed. Okay? If you do have any questions, please let me know, and I'll see you in the next one. Bye.